Dear students, we'll learn some concepts related to friction. If you kick a ball, after some time, the ball will stop. Why? Suppose we consider you are moving by a bicycle. If you stop pedaling, after some time, the bicycle will stop. The question is why? Writing on a smooth paper is difficult compared to writing on a rough paper. Why? It is difficult to walk on a smooth surface compared to a rough surface. Why? If I consider two vehicles, one is moving on a tar road, another is moving on a mud road. The second vehicle feels difficult to move. Why? Why the cycle or motor vehicle cannot move faster without air pressure in their tires? In all these examples, one thing we are observing. Opposite to the motion, a force is acting which opposes the relative motion between the surfaces. This force which opposes the relative motion between the surfaces, we can call it is friction. Now what is friction means? When a body slides over the other body or try to slide on it, then a force opposing the motion acts between these two surfaces of the bodies which are in contact. This force is called frictional force. Now the question is, if the bodies are not in contact, can't we get the frictional force? For example, if I consider this body is moving on the surface of the first body, it is not in contact. Then what you can say? What happens to the opposing nature? Is it decreases or increases? Yes, it decreases. That means when the surfaces are in contact, we get the opposite nature more. When the surfaces are not in contact, there is no opposing nature. Now this force which opposes the relative motion between two surfaces which are sliding one over other, that force is called frictional force. Or I can say, when a body is sliding over other surface, a tangential force is acting between the contact surfaces which opposes the relative motion. This force is called frictional force. Now what is the reason for the friction? We get the friction because of two reasons. One is friction is a result of molecular interaction, and the second one is interlocking of irregularities of two contacting surfaces. Now how we can say the friction is a resultant of molecular interactions? Suppose we consider two surfaces. On these two surfaces, when two bodies are kept in contact, electromagnetic forces act between the charged particles, that is molecules, at the surface of the bodies. Each body exerts a contact force of the other. The magnitudes of contact forces acting on two bodies are equal, but their direction are opposite, and therefore the contact forces obey Newton's third law. The direction of the contact force acting on a particular body is not necessarily perpendicular to the contact surface. We can resolve this contact force into two components, one perpendicular to the contact surface and the other parallel to it. The perpendicular component is called normal contact force or normal force. Generally it is written with N. And the parallel component is called friction. Generally it is written as F. Therefore, if capital R is the contact force, then you can write capital R equivalent to root of F square plus N square. That means when a body is placed on another body, between these molecules some adhesive and cohesive forces are acting. Adhesive forces are the forces which are acting between different kinds of molecules, and the cohesive forces are the forces which are acting between the same kind of molecules. Because of these forces, these attractive forces, the body gets an opposing nature. when it is sliding over that surface. This is one reason of the friction. The other reason for the friction is interlacking of irregularities. Suppose if I consider a smooth surface, even though it is very smooth, under microscopic view you can find some irregularities on the surface. As you are seeing in the figure, we can find the irregularities, that is ups and downs, that is elevations and depressions, as you are seeing in the figure. Similarly, if I take another body, this is also having elevations and depressions, as you are seeing. When this is placed on the first body, these irregularities, that means these elevations and depressions, are interlocked together. Because of the interlocking of these irregularities, the second body feels difficult to move on the surface. When you apply the force, immediately the body cannot move. When you increase the applied force at certain level, these irregularities, that is these elevations and depressions, they will be sheared off, they will be depressed, and then the body gets the motion. Again, when the body is stationary, these irregularities are erect, as you are seeing in the figure. But when the body is moving, when the body is sliding, the irregularities will sheared off. Therefore, I can say the static friction is more compared to the kinetic friction. That means when the body is stationary, when you apply the force, it experiences more opposing force. When the body is sliding, then it experiences less opposing force. This is about the interlacking of irregularities which causes the friction. Now, some important points related to the friction is, when a body is sliding over the surface, the tangential force acting between the surfaces which opposes the relative motion of the body, this is called friction. This is a result of molecular interaction. The friction forces is due to interlacking of irregularities of two contacting surfaces. The adhesive forces are cohesive forces between the contacting surfaces. Now, frictional force is a self-adjusting force until the surfaces are in contact or rest. Now the question is, what is the direction of frictional force? Yes, exactly. Always the frictional force is acting opposite to the motion. Now the question is this statement is correct? For example, when you are walking on a surface, you are moving in forward direction. In this case, in which direction the frictional force is acting, you know? No. The frictional force is acting in the direction of motion only. Now how it is? Suppose you consider you are walking on a surface. How you can walk on a surface? Yes, when you push the ground back due to reaction, you can walk on the surface. You are pushing the ground means you are applying the force along this direction. Now, the frictional force is acting between the surfaces along this direction. That means saying the frictional force is opposite to the motion may not correct in some cases, but saying the frictional force always opposes the applied force, this gives the correct statement. That is, the frictional force opposes always the applied force. In which direction you are applying the force, opposite to that, the frictional force is acting. And the second one is, the frictional force is a self-adjusting force. What is the meaning of self-adjusting force? That we see later. And you consider another example. If a cyclist is moving on a cycle, you know what is the direction of frictional force on rear wheel of the cycle, that is back wheel of the cycle, as well as front wheel of the cycle? The frictional force on back wheel of the cycle is in forward direction and front wheel is in backward direction.